Welcome, everyone, to another session of Codam Masterclass. For those that do not know yet, especially the ones that are watching us, from all corners of the world, of the 42 network, Codam Masterclasses are in-depth technical sessions on different technical topics. Very straightforward, right? Today, we talk about testing. Many of you might have already watched the Clean Code masterclass. So this masterclass is about testing because actually during that masterclass, many of you indicated that testing is another interesting topic for you to listen to, right? That's why I see that we have like a full room. I don't think that I've ever seen the room that full in a while now. So I'm very happy to see you. Who's going to give the session? Today we are welcoming Omer Karaduman, if I pronounce it correctly.
Good.
He has actually 16 years of experience in testing, specifically test automation with C#, C++, Python. So it rings home, right? It calls home in a way. So that's why we're super happy to have you. Also, Omer is right now a test expert at TomTom. He worked in multiple startups before, related again. Testing, 16 years is more than enough, to actually have you here, to share your knowledge with our students. With no further ado, because it's not about me, it's about Omer, and it's about you guys. Omer, take the stage.
Okay, thanks a lot.
Though there is one single administrative thing, because we had actually 558 registration for this event. Okay, so there is a bunch of other campuses joining us from far away. So we actually organized the Slido. I also shared the link of the Slido in the live stream. So whenever a question pops up, please include it in Slido, and Omer will address them at the end of the session. Okay? So even the people in the house, you can already do it now as the talk goes through, or you can wait, until the end because we're going to throw the catch box too. Okay? Yeah.
Okay. So, thanks, Victoria. As she mentioned, I'm Omer Karaduman. I have 16 years of experience around testing now. I started my career as a manual test engineer. Then basically I saw that automation is a bit more fun. So for 16 years, I started working on different areas related to testing. I worked in avionics projects with huge military standards that you need to follow. I also worked in startups, and right now I am working at TomTom. And again, they all had different aspects on testing. And today, the idea I had was, first of all, this, so that you can see what I have prepared. And the other thing is, we also had a talk with Victoria and Nicholas, and the suggestion was focusing on, something concrete so that it will be easy to follow, you will leave with a specific information. So, and there are topics around testing that we can focus, but I realized that whatever I had picked, it will not help you write better tests. The tools are online. You can find tutorials about everything. But the thing that is missing is usually the testing mindset. So what I prepared today is some information about why testing fails. Because all the companies, almost all the companies have testing procedure. They have dedicated testers, and still almost no product is bug-free. And today I will try to show you why that happens, what are those fallacies, those pitfalls. And maybe in the end, today maybe you won't leave with a specific idea about a specific tool or methodology, but you will have an idea about why any of those methodologies that you encounter might fail and what you can do to improve those. And this is something, actually, I will start this. This would be my first slide, and this would be my first topic. But I want to show you something, because here you see the color palette. It is gray, it is blue. But what I had in mind was this darker background. So actually, we just started and we already found a bug. And it's not our problem, probably. It is probably a bug about PowerPoint. But I think it could be cool and to talk about it. But one of the things that I want to have here, so we have Slido, you can ask some of your questions here. But during this talk, I will ask you questions. And I want this to be an interactive session where we can go over, the fallacies and test, your perspective and see, what we can do to improve that. And, let's just start the interaction. Say that, this is a bug you found. We have gray originally, now that you have blue. How would you are supposed to create a bug report for it, in theory, if you are testing. What would be the thing that you would do to create that bug report? Any ideas? At any hand movement, I will just pick you as a victim. So, yeah.
So, for which bug do you mean exactly? Like a blue bug, right?
Yeah, so this was supposed to be gray, and now it is blue.
Because the people from home couldn't hear it.
Oh. Oh, yeah, okay.
Yeah, I sacrificed myself, I guess. There were not many ends. I guess if we're just going to make a bug report first without investigating further, because we have to investigate further now, I guess we'll start with what's happening, what I see that's wrong. Okay, it should be black. And in the development view, it's black. Mm-hmm. This view, it's not.
Yep.
I would include this file because it's probably an issue in this file.
Mm-hmm.
Include information about what version of PowerPoint I'm using.
Yep.
All kinds of metadata like that, I guess. And then I think I try to reproduce it in a fresh file and see if I can do that and include that information.
These are all fair. And let me show you something. Okay, now look at this. Will you be able to catch something else here? I'm actually using a browser.
Oh, right. Good points. Yes.
Yeah.
So yeah, then I definitely include which browser I'm using.
Yeah.
And we'll probably try to see if it behaves the same in a different browser, and if I have local PowerPoint, if it behaves the same in there.
Exactly. Like even while creating the bug report, actually you are, doing further testing about, providing more information to the developer, So this is where it works because usually this is what happens. You create a bug report saying that, okay, this was gray. I opened in the browser and suddenly it was blue when we went full screen. And you don't include details like, I'm also using Linux, by the way. So there's Chrome. Chrome needs an update there. We can also see that there are all kinds of extensions Chrome has. So there are a lot of information that might be causing this error that we are seeing. And if you don't include, all those potentially relevant information, or if you don't test it yourself first, all those combinations, then you will send it to a developer. Developer will open the file with the local PowerPoint they have, and it will just work, and they will say, I cannot produce, sorry. And the bug will be closed. And this basically happens every day on real life, in all those big projects. So actually, we can even keep the microphones around because I want to continue with the interaction. So imagine that I gave you this. This is a flow chart of a small system that is supposed to be doing something. And I want to ask you, how many tests would you need to verify that this works correctly?
I guess first you'd have less than 70. Above 70, 70, negative, int, one above int max maybe, one above int min, one below. Is that about it? Also depends if it takes int or longs or the limits, basically.
Yeah, okay. These are really basically good textbook answers. Any other ideas?
Other inputs that are not digits, I suppose?
Mm-hmm. Of course, it depends. For example, if this is C++, and if this is accepting an integer, you cannot just push a string there. It will have to be an integer anyways. So it will be just about boundary checks, right? Any other ideas?
I'd say check if it's stored in A, check if it's stored in end.
Mm-hmm. Yeah. So you need
For
to make
example?
sure that it is actually doing something,
Yeah.
not just provide the inputs. Yeah, that's also fair. And other ideas?
No input?
Yeah, that might also be possible. Some languages allow that. You may skip the arguments. Anything else? Well, yeah.
If it's a function, how many parameters does it have, and how does it combine with the other ones that you put into that function?
Yeah. Okay. That can also make sense. And actually, I mean, what you are saying is they are all correct. And you actually, while unit testing, you will actually do that. The thing is, I mean, it also depends a lot on the context. So, when I ask you how many tests, you actually go here, try to calculate the number of, different inputs that you can take, what you can provide with it. But testing is actually a bit, includes a lot of skepticism, because this is what I show you, but this is just a picture. This is not the software you are testing, or this is not the intention what the software should be doing. And this might be the context. So maybe this code is a part of an anti-missile system, and it runs on a distributed computer network with 50 computers, and it evaluates threat levels, missiles, and it calculates countermeasures. And the threat level is a letter, an ASCII letter, and only the threats in the range of AF should be, calculated. And it does a lot of filtering, and storing actually means, connecting to cloud, verifying credentials, and everything. Now, with this in mind, I mean, things change a bit. What you say still makes sense, but if this is the system that you are supposed to be testing, then you will start thinking about other things, like what happens if we oversaturate the radars? What happens if one of the computers just dropped from the network, or there's a problem with the filtering, or storing fails because of invalid credentials, or something along the way, or maybe there is a security threat there. Those credentials might actually be stolen by other people, and even with the numerical thing, actually, see, so 70 is basically F, in capital F in ASCII code. And this check, maybe, okay, it might have filtering before, but it is doing a smaller than. But the requirement says, yeah, it should be, in a closed range. So F should also be included. And this is what I say, why I say, testing requires a bit of skepticism. What I show you, and this, for example, as a tester, this happens to me as well. I will be testing a module or software piece, something like that. And if I go talk with the developer, and they will say, yeah, this is what it is doing. This is, well, I mean, it just checks the numbers and stores it somewhere, and, it will be very easy to test. So if I just believe them, I will just, create this. And once I create that, I also need to support that these tests are enough, right? And for that, what people usually do is checking the coverage values. And for a case like this, actually, even 2 tests are enough to satisfy the coverage requirements. Just like she started at the beginning, you can provide 69, then 70, and both paths, this predicate here, all the statements, in theory, they will be covered. So I can create my test report. Yeah, we have 100% coverage for everything. I mean, we've tested exhaustively. We did, ISTQB style boundary value testing. But in the end, we, put it to the system, and it doesn't work because it cannot, fight with the load. So, I mean, it's not always like that. For example, if you're working for an avionics project, and I did it for like 10 years, when you have requirements, it will be very detailed. And it will be reviewed with multiple people. But still, the code coverage, for example, it will be used by, a lot of people. The developers actually like that, like seeing that, okay, I ran my unit tests and the coverage is increasing, I'm doing something good. And managers actually also love that. I mean, when you start working at some place, if you check their testing strategy, you will probably see the 80% number. They will say, we test until we have 80% coverage. This helps, but let's check this example. So here, I mean, by the way, just out of pure coincidence, I have 79% coverage. So, I mean, it was just a coincidence, really, but yeah, it is a good coincidence in this case. So I use Python because it looks like pseudocode, and yeah, it is simple to just have an executable in like 15 lines like this. And here we see a code, and it is actually, I mean, it covers basically most of the cases that, yeah, we need to cover. It checks if the value is really an integer. It checks if it is in the accepted range. And yeah, otherwise, yeah, it results, returns too large or too small. And when you look at this, you see that these red lines are not covered, which means we didn't provide an invalid value, small or larger values, but we provided an accepted value. So obviously, I mean, this is not well tested yet. So the manager sees the 79 numbers and says, yeah, we need to reach 8%. Please just, test it further. And someone comes and says, yeah, this is actually, I mean, this is just numbers and all the checks are in place. So I will just, write a small test, something like this. Check range with a string, with none, with a floating value, and why not test all the numbers from -100 to 100? And I mean, it is a bit an overkill, but maybe the developer was a psychopath and he injected a code here, like what if it is -75? Coverage helps you actually catching the psychopaths. If you are implementing, testing the features and something is not covered, yeah, there might be something risky going on about that one. So we have these tests and we have 100% coverage. Are we done? At least no one is saying yes. I mean, let's look at this tester. Do you see any obvious errors, on this one?
We're never checking what we get back.
Yeah, exactly. I mean, this is covering everything, but this is not verifying anything. So we don't have any assertions, any checks. It actually just verifies that it doesn't throw an exception and just fails in the middle. And this is one of the main fallacies about coverage. Because as I mentioned, I mean, managers like seeing that 80%. I'm developers like seeing their code, coverage increase. But the thing is, if you are not reviewing the tests properly, then it doesn't really mean much. I mean, actually, for example, when I was working in avionics, we had very hard, strict coverage requirements. And when we turn on the system without doing anything, we will have more than 50% code coverage without, just by turning it on. Because all those initialization sequences and other stuff, they already cover some piece of the code. And it doesn't mean anything. Those pieces are not tested. We basically did what is called a smoke test. And that is basically you turn the engine on and check if any smoke is coming. Probably the first test you should do, when you are buying a car, for example. And again, just turning on the system, verifying that it works is a smoke test, but it doesn't mean that those features are covered. So let's improve these tests. Now we separated them and we put assertions. Okay. So we are actually still checking the same thing, but we are asserting on the return values as well. Now, again, we have the same coverage. We didn't improve anything related to coverage, but are these correct? Or are these enough?
Yeah. First thing I notice is, well, actually, I don't know in Python this might be enough. I'm wondering if double equals checks the type as well. Well, yeah, I guess it can't be the same if it's, yeah. Never mind.
You mean here in the?
Well, for example, assert result. In some languages, you might want to triple equals, but I don't think Python even has that.
No, this is valid Python code, so you can trust me. And it just asserts if the given predicate, in this case, the comparison is correct or not. Otherwise, it throws an exception.
Right.
I mean, think about our previous example, actually. Basically, I mean, it will connect to something similar. I mean, this is an overkill. We, again, have ranges, because we are looping with, unnecessary number of parameters and everything. Let's just ignore that. But the thing is, This will pass code review. Another developer will look at the code, they will look at the tests, and they will say, yeah, this is okay. Okay, yep.
So probably the before doing this kind of checkups, you need to figure out, is it really like the points where you should check this, where you should do the test? Because maybe, okay, in this range it's fine, but maybe 51 would be like, at 51 it would be another result, and science it's, so it's like in mathematics, you have like kind of examining the function, like methodology. So you see at which points the function changes properties like dramatically.
Yeah.
And you check like before this point, like after this point, after like before like previous point. So you check like the regions.
Right.
Each region should behave like in specific way. So you need to like map it before you like check the function. You need to map which region, and you already know how each region should behave. In this case, before this, we should really to check if its values is really relevant to test, or it's just random from our head.
Yeah. Okay. That you have a correct intuition here. I mean, what you say is especially important if you are testing like mathematical, a complex formula like a filtering algorithm that can have different behaviors for different ranges. It can go, negative, positive, things like that. This is a bit simple. Some of what you suggest is actually also covered with, these extra tests we do in these for loops. And maybe there is another function before that which ensures that the values are always between minus 100 and 100, which means that in those cases, these tests will cover all the specific potential inputs that we can have. Yeah.
Honestly, what I see, it's like on the code, because it definitely passed the review, but it might be wrong, because elif value is less than equal 0, and value is less than 50, and it's in accepted range. And so we have from the range, and it's
Ranges
okay.
are open-ended, by the way, in Python. So 0 is included, but 50 is not, for example, in the second.
So it's passing to the next line.
Yeah.
So it's so the second thing I would say, because we definitely have this desired space from between 0 to 50, and this is the most crucial, because we want, maybe another function depends on it. So checking this would be cool. But any other point, technically, we just took arbitrary range, which, in this case, in this machine, let's say it may work, but on different computer it may not. So better would be just the points which are exceeding the range, or rather sample randomly, some sort of theories, like we can use it. This.
I mean, what you say is also about the context. I mean, context is not about requirements or what it is supposed to be, where it is supposed to run, how fast it is supposed to run. And you usually have different separate tests for that, like stress tests, performance tests, to measure that how it behaves on the potential systems that it will be loaded on. I mean, I didn't want to trick you too bad, but I mean, we actually have the same fallacy here. And, at first glance, it will look stupid, but I will explain why I picked this example. Because the requirement here, for example, might be like that. And it says if it is between 0 and 50, both included, it should return true, otherwise it should return false. And you are probably thinking, well, if I have that requirement, I won't write this code. I mean, when you see it side by side, it doesn't just make sense, right? But the thing is, I mean, I had almost exactly the same thing in a software that is sold by like millions, a very expensive piece of software, and everyone was actually happy about it, even the customer. Even they didn't complain that there was a bug there. what happened is, I saw some requirements and I decided to test it myself. And I was working on the UI level. So I created my test cases according to the requirement. And I created like 15, 16 test cases. And 12 of them failed. And it's weird because we were given the software as pre-tested. It passed along from a lot of testing stages, unit tests, integration tests, system tests, and I have the integrated product. They have 100% coverage on this specific module, but we still have failures. So I was curious. I decided to talk with the developers about it and told them that, yeah, I have 16 tests and 14 of them failing. And the first response from a developer when you say something like that is, getting angry, basically. Because, no developer just goes around and just, randomly types code and expects that, yeah, someone will accept it. And because as a developer, you want to create something working. You want to create something you are confident with. Sometimes, yeah, maybe you are just creating a prototype and you don't care about clean code or anything, but at least, you are supposed to be doing what you're supposed to be doing. So we started talking with them, and they actually gave me the coverage results again. They said, yeah, we have the tests. All tests are reviewed. The code is reviewed. We have 100% coverage for that module, and you can't blame us for not testing it enough. And I actually described them more or less the same example. I told them, yeah, I don't know about what you tested, because I have the errors, I have the bugs. They are reproducible. They are not just a one-time thing. I also reproduced in another system. It is reproducible. Just believe me. It's also something the testers have. We get excited about finding bugs, but sometimes convincing developers that there's a bug there, it can be a bit tricky. And that day, actually, they just left the meeting. It was an online call, and they said, okay, we won't argue about this further, and they just closed the meeting. Yeah, it doesn't feel good, to be honest, but a couple of days later, we got an email from their product owner, and they told us that basically none of them had any idea about the requirement that we are testing. They didn't even know where we found that requirement from, because that piece of code, it was working in a previous project. So they just took the module, integrated it into the new project, and it just worked. And no one was complaining, because even the customer, they gave ranges, combinations, and it was about the speed and the distance to a specific point. To be able to test that while driving, this is what customers do. For example, for places like at TomTom, we create navigation softwares, and the customers install it on their software, and they go drive testing usually, and you drive and try to catch those issues. But those combinations, it required a specific speed and specific distance to a specific point. It is hard to create, and you might just oversee it when you're driving. So, no one was realizing that. But with the tester attitude, with checking the features, and we were able to catch it. And catching a bug, actually, it is an exciting thing for a tester. As a developer, when you are writing a unit test and you find a bug, you fix it, you continue. You don't go high-five each other. As a tester, we don't go high-five each other, but finding a bug basically makes us feel useful. Because I will tell you a specific story about that later. But finding a bug yourself means that you actually covered something that could have been found by the customer, and which would cost much more if it was found by the customer. And, oh yeah.
In the assignment, it says between 0 and 50 both included, and in the code, it's actually 50 is not included.
Yeah.
Yeah, because if you look at the code, it's the same sentence as written on the human language, but it's written on the machine language. And in this case, it's just wrong translation.
Yeah, definitely. And actually, let me tell you why this happens. I even brought some stuff. And this is called white box testing. And as I mentioned, it happens in real life. why it happens? Because when someone else reviews this code, and it will be another developer usually, because developers don't ask testers to review their code most of the time, and the developer doesn't go check the requirements. They check the code, they say, yeah, okay, I mean, I understand what is going on, I understand what this code is supposed to be doing, so let's check the tests, and the tests are like this. They check both of them, and they are compatible. And it makes sense, because this was what was supposed to be doing, right? They don't have any other reference. And even if they see the requirements, maybe they read it at the beginning of the project, and they saw this 0 and 50, and there is 0 and 50 there. But I mean, it's not the same. And so when you test by looking at the code, it is called white box testing. And white box, I mean, technically it should be called transparent box testing. And you check the code and you modify your inputs according to the coverage you get, for example, or the branches you have in the code. But white box testing, I mean, it can be very useful. It can help you populating your data, for example. But just as you saw here, I mean, it can be problematic. And as an analogy, I actually brought these toys here. So this is, I don't know if everyone can see it, but this is actually a transparent padlock. And you can use this if you want to learn about lockpicking. And as a hobby, I was curious. I watched lockpicking Lawyer, for example, a lot. Actually, I can even try picking that while talking. Now, the good thing is, I don't know if probably everyone doesn't know how a lock works, but the thing is, there are pins here, and there are springs. The springs push the pins downwards. And what you need to do is you actually give a little bit of tension so that the pins can be squeezed between the cylinder and the body of the pick. Then this is called the tension tool or something, and this is called the pick. You enter in, and you can, with this type of transparent lock, you can see what you are doing and where each pin supposed to be at. So seeing this, I was actually excited because the first time I tried it, I think it took around 10 minutes to unlock it. And it is without any previous knowledge. I was just watching the pins. I was trying to turn it. I was just, playing around with it, and it just opened just like that. And I said, okay, maybe it was just dumb luck. I will try it again. I tried it again, and I was able to open it. And I said, yeah, maybe it is because I am looking inside it. Let me close my eyes and try it again. And again, it was easy. In a couple of seconds, I was able to open it again. Then I got a bit ambitious, and I bought this one. It is not a high security padlock. I mean, it is just something from Action, very cheap, probably very unsecure. Maybe I can even open it by forcing it like this. And I think it has been almost 2 months since I bought it, and I was able to open it only once. The thing is, I cannot see what is going on. I know the logic, and I can do this one, eyes closed, but I can't see, what is going wrong, if I am pushing too hard, too low, and I am trying to feel what I am doing wrong, but no, there is no feedback that is given back to me. This is much harder. And then I realized this actually has a very smaller opening, and my tools were actually not the correct ones. I should have smaller ones for this one. So this is much like the difference between white box and black box testing. When you are testing a white box, you see what you are supposed to do anyways. And what you are supposed to do doesn't reflect, the real life. In real life, you will have much more complexities. So this is what you need to know about coverage. If your tests are reviewed well, and if you are sure that you are actually covering your requirements properly, then coverage really means a lot. Coverage really shows you what kind of tests you still need to add. But careful, it doesn't show you, as I mentioned, a covered line doesn't mean that it was well tested. In that sense, this means a lot. When you have missing coverage, then you should be careful. Those missing lines probably means you still need to do further testing on it. But never trust on it, and never trust on full coverage. And after this, I am really sure that you will see that 80% coverage somewhere, and just have a chuckle, and just out of curiosity, ask them, why they picked 80%, and they will say, I don't know, it came from a textbook, they tried it before and it worked, or it is just, industry standard, they will even call that. So just don't believe that. Actually, it kind of, connects to the same point, it depends on the context, and you need to be skeptical about what's going on. And what we are talking was mainly about quantifying the quality of the software. And that's a big fallacy because, whenever you are doing something, you want to have a quantitative measurement. Like, it is not always gut feeling saying that, okay, if you don't have provable numbers, how will you verify, how will you prove that your software is actually mature enough, good enough for release? But you cannot just blindly use numbers to assess the quality. And imagine these two scenarios. You have two release candidates. You ran all the automated tests. All the automated tests are perfect, by the way. They are up to standards. They are up to the requirements that they are supposed to be doing. One has one failed test, the other one has 20. Which one would you rather release, the first one or the second one? Yeah. Depends on what?
On what's failing.
Yeah. You need to check what is failing. And here, for example, this might be PowerPoint, like we are using. That one failed test is whenever you try to save the file, it crashes and you lose all your changes. But the 20 failed tests are like this one, like the color is changing. And developers solve that. Actually, this is why you have those release notes. If you read, actually, I usually get curious about the release notes of a specific software. It's like a huge block of text, but I get curious what kind of things they actually fixed, because it gives me insights about, how they tested it, what kind of issues can happen on a product like that one. And I read that, and then there will always be a section like known issues and bugs. Well, there are issues, there are bugs, but they still release it, and it is really normal. And if you are a gamer, you are probably more used to it, waiting for a game for years, and suddenly you have something and it is not even playable. And it's like that. These numbers alone, just like the coverage values, they don't mean much. What it might help with is, for example, there is something called FMEA. You do failure mode analysis or risk analysis. You assign a point, like a risk value, to each specific test, and then you can compare. This might have a value of 100, but this might have a value of 0.1. So then you can have a numerical comparison that you can do. But the thing is, you can't do it blindly. It, again, depends on the context. It depends on the requirements. It depends on the domain knowledge, the experience that you have while you were assigning those values. And I mentioned that I worked in avionics, for example. In avionics, this is very crucial because those failure modes end up with criticality levels. And the criticality level is something interesting because it is not something you will see with mobile applications or navigation. The criticality means how likely a bug can kill people. Unintendedly, of course. Well, intentionally, they are war machines. They will do something. But unintentional, for an aircraft, how likely a bug can kill the pilot or shoot a missile, So there will be huge graphs about potential failures that can go badly. There will be weights. It will be analyzed with domain experts. It will be cross-reviewed, cross-checked. And if it is level A, then you will have more stricter standards about testing, coverage, and everything. And if it is level E, DO178 says, well, you don't have to test it. We don't care if you test it or not. And E is the most common example is the infotainment or entertainment systems in the planes. And that is probably why those entertainment systems don't really work well when you are on a plane. Yeah, probably, because, I mean, you don't have any contractual obligation. Of course, you want to release something shiny, so maybe someone just, tries to launch it, watches a movie, maybe play a couple of games and verify that it works. Then you hop on the plane when everyone opens up their, monitors, then suddenly, yeah, nothing is working, everyone is lagging and everything. But still, there are simpler things that you can quantify, and I think one of the best examples is the performance test. And basically, performance test can mean something very simple, like the maximum duration for this functionality to complete is, say, 5 seconds. Or it can be about CPU measurements. It shall not use more than 20% of the CPU or more than 2 gigabytes of RAM. You inject your probes. You try to, load your application with different kinds of data to see if you are actually passing those limits. And in that sense, it gives you, a pretty confident value. But of course, I think this was mentioned, it can depend on the computer. So you should be referencing the results always, with the same hardware and the environment and whatnot. But we actually recently have a problem about that. I mean, not exactly a problem, but it still tells something. And basically, I was part of a performance testing team. I am still part of the same team, but we are not doing performance tests. So we were trying to find a way to see, not just fail the test because of performance, but to see if there are any sudden spikes going on. So what we did was something like this. We got an average value, something like that. And for every time we were getting a value, if it was larger than the expected value we want, we were checking if it is, between like 15% range. These numbers are all arbitrary. They are not, they are just things that we made up. And it is okay. It is good enough for us because we just wanted a bit more confidence. And so looking at this, I mean, can you imagine what our problem was with this? Yeah, maybe someone else.
You can't really see by how much it exceeds the threshold or the expected value.
Okay, yeah, here, actually in our log, I didn't want to type it all, but yeah, in our log, we had things like that. This was what we were expecting, and this is what we got. Anything else? Yeah. Okay.
It depends on the context, but if the expected value could be a negative value, then I think this won't work as expected.
Yeah, actually, yeah, that's a good point. But for us, I mean, it was all about durations and the CPU usage and memory usage, things like that. So expected value was always positive. So, I mean, maybe we can even discuss if that was a valid case, because we discussed what could go wrong. I think, yeah, we have an answer from there. Can throw it. We need a catapult, yeah.
But if it would overflow, it would still say it's fast enough, right?
Actually, that's a good point. But the thing is, I mean, this is just about, those spikes. But on top of that, imagine we already have a hard cut. If it is already, above that time, about that duration, the test will be killed anyways, and we will know that it took too long. The dilemma we had was actually a bit weird, because we started discussing what will we do if the current value we got is smaller than the expected value. Is this a problem if this is about duration and you just wanted to make your software faster, right? And maybe someone implemented some improvement and now it is faster. Do you think it can be a problem? Yeah.
If it is much, much faster, there might be an issue with what is actually being run.
Yeah, actually, that was the thing. We said, okay, I mean, we want it to be faster, but I mean, what if it was too fast? Something magical happened, or someone really improved the algorithm so that it is now 10 times faster, 100 times faster. And I mean, this can happen and again, it is related to the context and the test you are having. But imagine that you are testing a REST API. You are sending calls, getting the results, checking if you got results, and depending on that, you are measuring how much it took to send the query and get the response. And imagine that in the test, you forgot to check the status code, and they moved the pages on the server to somewhere else. Now the link is not working, and you are getting 404s. The operation that used to take 5 seconds is now taking 50 milliseconds without doing anything. And this again, in theory should be caught by reviews or anything, but we actually refactored this a bit, and we basically removed this check. But we say that if it is smaller than, let's just, raise the alarms and fail the builds or anything, but at least send a message, to the analyzers that will work on that so that we can see if something went bad or actually it was a real performance improvement. So this is one example, about quantifying the quality. But as I mentioned, I mean, you will have those coverage statements. You will have requirements coverage, for example. And requirements coverage, you will probably come across that. And requirements coverage is usually done. You give an ID to a requirement, and you put a comment in your code saying that this piece of code actually implements this requirement, so that people that are reviewing can go back and forth and analyze, if this thing is being implemented correctly. You can do the same with tests. You write your test and you give again a requirements traceability, and so that you can see which tests are implementing, covering those requirements. And if you don't have the context, if you are not reviewing them properly, you will have the same thing. You will have 100% requirements coverage, but maybe they are just, in the end, you are just putting strings in the code. If it is not reviewed properly, then you will again have the same thing. And the point is, numbers can be made to lie. I mean, numbers themselves don't lie, usually, as far as I know. But you can make them lie. Actually, I had a statistics teacher, and she would say that, statistics is the art of lying with numbers. So there's something you need to be careful as well. And this is another textbook suggestion. And again, this is something you will see a lot. And what it describes, this is called the test pyramid. And it says, on the bottom, the first level of tests will be the unit tests, and you will have a lot of them. Then you will have integration tests, where you combine your modules together and do some further testing on them. And on top of that, you will have end-to-end tests. Actually, in some images, you will see manual testing here, drawn as a cloud or something. And because this is mostly, representative of the automated tests for most people. But again, if you have manual testing, it will probably be here. And the suggestion is, as I mentioned, have more of them here and less of them on the top. And do you know why it is like that? Have more unit tests and less end-to-end tests? Yeah, maybe. Whoop.
Mostly because complexity grow, and end-to-end test in this moment, we have so many variation which we really cannot test.
Yeah, that's basically it. I mean, the complexity grows, and with complexity, costs also grow. Running thousands of unit tests, it can be completed in a couple of minutes, but running 10 end-to-end tests, UI level tests can take a couple of hours, because you need to put system into specific states, you need to click, and when you find a bug here, also it is very hard to find where the bug actually started. Yeah, but if you are just unit testing, I mean, most of the time you will be just unit testing a single method or a class, and you will know where to look at. When it is end-to-end test, when you create a bug here, a team will actually gather. It depends on the context, of course, but for example, for my case, a team will gather to analyze the bug. They will do some kind of triage, they will send it to a team that they think should be responsible for that bug. They will do another triage and see, you know, if it is related to one of their components, and depending on that, they will assign it to a developer to fix it. And it can be costly, and it gets even costlier when it is manual and when it is actually found by the, you know, if this is the pyramid, if manual testing is the cloud, the customer is actually like above the class in a silver throne, you know, with, you know, sitting there waiting for the product to be sacrificed to them. And if they found the bug, then yeah, it is much more problematic. And if they don't find the bug as well, it is even more problematic. And yeah, recently this happened with a car manufacturer. If you switch the radio to a specific frequency, then the car would crash. The computer would actually stop working. I mean, I don't want to say the name here, but I mean, you can find that story. It was very recent. And it is something that was just overlooked because it's just a radio. I mean, how bad can it be? I mean, maybe it will just be, you know, there will be a parasite or something, but it actually crashed the car. They had to recall the cars, you know, to replace that computer system. There was no easy way of solving it. So it can get really costly. And that is why, I mean, this is the most common suggestion. People say, yeah, this is what we follow. And there's an alternative to that, and this is this one, the inverted test pyramid. And this also makes sense. But why? And we talked about, yeah, the cost, complexity, and everything, but why would this make sense then? Ideas? Yeah, okay.
This pyramid makes sense when you're not sure about is the bugs exist or not. So you can first detect that it exists, and after try to find out where it exactly it is.
Can be, yeah. Yeah. Oh, there. Okay, maybe first here. Yeah.
I guess the end-to-end tests will test actual use cases that programmers don't think of naturally.
Mm-hmm. That's also a very fair point.
Perhaps projects that are still being developed, not done yet. Perhaps that the user makes like an issue saying like, I want this feature, and there are no unit tests for that yet.
Might be. I mean, in theory, if you have the code, then you should also have the unit test. That's, I mean.
I don't have this feature. The feature wasn't there yet. Then the issue gets made, and then new unit test gets made for that to create that feature, perhaps.
Yeah, it is an interesting way of describing test-driven programming, I will say, test-driven development, but on the end-to-end level, because test-driven development usually starts here, but on the end-to-end level, you can also do that, and that's also fair. One more idea here? Yeah.
I would say that again depends, because, for example, I don't know, like a REST API, let's say, we have very strict rules, very limited on number of methods. So there is not many variation we can test. Therefore, from other hand, when we utilize this, we create great complexity. Depends on the integration. It depends on the relation between how we use those methods, those functions. And it's literally growing together with complexity of the system. Let's say we want to have very complex system to doing something crazy based on simple principles. Therefore, there is no need to test again and again and again, because let's say we can even prove in some moment that we executed almost all valuable unit tests, but the integration still will be problematic.
Yeah, I mean, that's also fair. Actually, yeah, this also kind of connects to the use cases about the end-to-end test. I mean, in the end, you can have millions of unit tests, but the customer is not using your unit. I mean, they don't care what you do on the unit level. They care about this one, even the higher ones, because this is what they will be using. And this can sometimes make sense. Again, it depends is actually the correct answer, and it might be the, the generic correct answer for everything testing related maybe. The thing here, for example, imagine, actually, I again have an experience about that. Yeah, I think, 16 years you'll come across a lot of things. For example, in one case, I was working in a company and they decided to completely rewrite their architecture because it was a monolithic architecture and they wanted to go into a service-based architecture. So which means that, they will try to reuse as much as possible from the old code. But in the end, they will only change the core module and the rest would stay the same. Everything will be refactored. What they wanted was at any point, the overall functionality should not be broken. The problem is they really didn't have any end-to-end tests. Well, and the unit tests were now obsolete because the code was changing. And it is actually one of another point about this. People say this and they say that, write unit tests for every piece of code that you have. But if you are not careful about how you write unit tests, because there are concepts like mocking or stubbing, where you actually, instead of using an existing function, you fake it. You write your own implementation. And you use that one. And later, maybe they change the arguments of that function. And now you have to maintain not just the unit tests, but also the mocks, also the fake data you have. And with small changes that happens in a different component, it drizzles down to the unit test that you are trying. And it can cause a dependency, a complexity that you were not actually ready for. It can be avoided with using, good testing practices and things like that. But again, it is something that depends on the context. So here, and another example could be if you are, again, this is something you will come across, working with legacy code. They will give you a code that is 30 years old. They say, we want to rewrite it, but we don't want to break anything. You cannot just go, let's write a module, unit tests for this module and see, and refactor it slowly. No, you will go heads on. You will refactor a lot of things. All those unit tests will be obsolete. So instead of writing unit tests, you write your end-to-end tests, verify the current functionality, then start changing things and ensure that it is not broken. But another thing is, imagine your projects. I mean, as far as I know, you write, homework-style projects, you work on things. And for you, writing a unit test, at least one unit test per function, it might actually not make sense. Some of the functions will be too simple, some of them will be too obvious, and you will anyways have that fallacy to fall into that trap of seeing the code and writing the unit test for it. And it can make sense as the complexity increases, but for you, maybe it is better to go with an integration test or an end-to-end test. Or I have a cousin, actually. I mean, he works in a hyper-casual game development company. And what they do is, they see a gaming trend, and they just create a mobile game in like 2 weeks and put it on the market and see, if it will work or not. And in 2 weeks, they actually don't care if the product has, high coverage in the unit test or anything. They just deploy it and see if it is working without crashing and if it is doing what they want to do, and if it looks fancy, then they just release it. So it will depend on the context. This is the most common textbook example. This is exact opposite of it, but this is also true because this is the only best practice that you need to follow probably. I mean, blindly following best practices itself is not a best practice. You need to think about the context, what you are doing, what you are trying to achieve. So, if, for example, I think we are live on YouTube right now, right? So I probably have friends watching and they know that, I've been working on test automation for years and I'm actually pretty good at it, I would say. And I like it because of these reasons. When you are manually testing something, it is not always repeatable, like we talked about the color issue that we had at the beginning. What happens, if you don't provide all the input, something goes wrong. But the automation gives you that idea. When you repeat the automated tests again, you know that the computer will do the same thing, exactly, almost exactly. The timings might change, and it is something you need to be careful, but it is much repeatable than a manual test. They are reliable because you know it is, because sometimes when you are manually testing, you take shortcuts. Yeah, the page is already open. I want just log out and log in again just to verify the, follow the rules. It is almost always faster and it is integrable, but the problem is it is dumb. And at least for now, I am sure that in a couple of years we will have AI systems, which can analyze your requirements, which will have domain knowledge from other things, which will analyze the bug reports that you had before. And actually, I want to be the one inventing that, but I'm not there yet. But for now, I mean, it only does what you are telling it to do. And if you don't, you can't give it the feeling. You can't really easily force it to context of the application. You just give it inputs, and it just repeats those chores for you. And because of that, some people even believe that you cannot actually find bugs with automation. I don't agree with that, because if you are writing feature-specific automated tests, then if the feature is not correctly implemented, it will find those as bugs. But otherwise, if a test has passed and if someone hasn't broken it, intentionally, then it will just continue to pass, and it will not provide you any value. The value it will provide is like some level of quick confidence, because you will see that once you run all those automated tests and you release it, you also do your manual testing maybe, and you release it and customers are happy. So you build some confidence on your automation test suite you have. And what can happen is, for example, something like that, again, I experienced myself, and it is called the dancing monkey problem. So you have a full automated test suite, say that it is like a website, web server kind of thing, it's doing some online stuff, and you have automated tests for everything. You cover all the requirements, and you ship it to the, release it to whatever, and the customers start using it, and you get a call, and they tell you that, okay, it's perfect, as usual. I mean, everything works greatly. We couldn't find any issues. But what is that dancing monkey about? Is it an Easter egg or something? And you will be surprised what dancing monkey. And you open the website yourself, and there's a monkey there, doing a silly dance, some animation, something like that. The thing is, if you didn't tell the automation to look for that dancing monkey, it won't look for that dancing monkey. And if it is not blocking anything, like if there is no buttons or anything behind that, then you won't be able to see it. If you were also adding a couple of manual tests, exploratory tests, something like that, then you will obviously catch it, but automation tests doesn't have that, vision, basically. And, you might think that, yeah, it would be very easy to catch. I'm dancing monkey, what you're talking about. But what I experienced was, for example, we had a hybrid test suite. Basically, the tests were automated, but it would come to a specific point, and it will say, okay, go to the radar system and just plug off the thing, from the other thing, from the other hardware, so that there will be a communication problem. We will literally have steps like that, like pulling out the cable or breaking something, in the middle of the test. And so the thing is, a tester, a manual tester, who is actually good with their domain, is looking at the screen. The automation tests, they are doing something. Everything was going fine. And towards the end of the project, end of the release, one of the project owners, he came and decided to have a look, and he was shocked because the fonts were incorrect. We had no idea about it. No tester was asked to check if the fonts were correct. No, we had no requirements about the font size or anything. And so we didn't report anything. I mean, for us, yeah, maybe they just decided to change it. I mean, it can happen. So dancing monkey is very abstract. Incorrect fonts, it happened in an avionic project, like the most, stricter rules in place and everything, but still it can happen. In that sense, I mean, I still like automation, And I like building test automation solutions, but I also know that it is not really trustworthy. I mean, it is trustworthy, but it's a bit dumb. So use it cautiously. We don't have much topics yet. I have actually 2 topics, and they both basically require their own masterclass. But I just wanted to give you some initial hints. So maybe if you can, if you want to follow that path, if you just want to try out these things, it might be helpful in the future. And one thing is test-driven development. And to be honest, I mean, it's a great idea. And how it works, let me tell it to you if you don't know about it. You start with an empty canvas. You open your source code, and you first write a test without writing any code. Because, for example, you will write that range checking thing. The first requirement is, it should not accept invalid values like a string. Then you write, you pass it as a string. It has an empty value, and the test will fail because you were expecting a false value, but it didn't return anything or just return true. It should fail. Then you implement it. You do the invalid check. If you need to, after doing those code changes, if you need to do something else, you do a bit of refactoring. Then you rerun your test suite, verify that everything is passing. Then you write your second feature, test for the second feature, and the loop continues. The good thing is, at each step, each test you are adding, like imagine the first case where we had these check range tests and they weren't asserting anything. You won't have that case because you need to start with this. The test should fail first. This ensures that the test you are writing is actually adding some value. Another thing is, as you don't have the code yet, you don't have that fallacy to, you don't have that bias to check the code to see what kind of inputs you should provide, but instead you are looking at the requirements, and it is helping you develop the application. Just let me see. Okay. So by following this, write failing test, make it pass, and refactor approach, you are actually getting rid of all those fallacies. But the problem is, it is really a different mindset. I am a developer and tester for 16 years. Whenever I try this, it looks really easy on the tutorials. I try to apply it to my project, and I get stuck because for me, it just feels natural. I just want to write my code because I know that feature won't fail. I know ins and outs of everything. I will have all the necessary checks in place. I just don't want to do that. And so in this sense, it's a bit tricky. It's a bit hard to make that switch, but people who can make that switch sworn by it. So give it a try. But even if you don't, I want you to do something else. And imagine, for example, you are working in a huge system and you found a bug here and you have these unit tests, integration tests, and everything. What happens usually when we create a bug? The developers fix it and ship it, send it to us, and we test it and verify that the bug is fixed. Most of the time, people don't think, why it hasn't failed here, or how it actually went all the way towards there. This is a discipline that you can have. In fact, I think all those years, there was one team that was doing this very meticulously. And I worked there, for almost a year. And for a couple of months, I was not able to find a single bug. They were coming up with new features, but they have kind of a test-driven development approach. They were testing, their software really nicely, on the unit and integration level before giving it to me. And they were doing reviews and everything. Because of that, I wasn't able to find anything. And during the stand-ups in the morning, they would ask me about the test results. I would have a sad face because nothing is failing. This, it's weird, but it really, if nothing is failing, I am there for nothing. Maybe something, and on the other hand, maybe something is actually wrong, and I am not capable of catching that issue. I mean, in both cases, it makes me feel bad. So I want to find some bug. And finally, after a couple of months, I found my first bug. I'm excited. Yeah, I found it. And I gave it to them. So the first thing they did, they checked their tests. They checked the path, where it should have been caught. They checked that module, and they realized that there was a specific condition that they actually didn't cover there. And what they did, they didn't actually fix the issue yet, just like test-driven development. They wrote a test at the integration level, also unit level. They verified that the bug I sent them really exists on that specific module by creating that. Then they continued with it, implemented it, verified that those tests are passing now, and they gave it back to me. And during this whole year, I was able to find a total of 2 bugs, nothing else. So, well, in the end, I was fired together with them because of a downsizing. But yeah, so I mean, yeah, writing perfect code might not mean the best thing in your life. And this is the takeaway, you need to have. I mean, as I mentioned, maybe test-driven programming is a bit weird, and it might be strange to start with it, but at least have this approach. Even in your small projects, if you come across a bug, even if you don't have unit tests, think about why didn't you think about that scenario while writing your code. I mean, it's a slippery slope. As a tester, for example, I tried creating mobile games, but I was testing it too much. I was trying to make it work in every condition, every kind of phone combination and anything. And in the end, very basic mobile game, it took like 4 or 5 months. And before I could release it, I mean, the hype was over. And I was just, I just played it myself, basically. But it didn't sound too right, but okay. This is my final point. And it's about testability. Again, this is a topic that that can take a lot of hours to discuss, but I will give you a shortcut about it. As here, I mean, every software is more or less testable, but according to you, I mean, what makes a piece of software more or less testable? Yeah.
I guess to what extent you can beforehand know what you expected to do exactly?
Yeah, that can be it, yeah. Because sometimes you won't even have requirements. They will just give you the software and ask you to test it, and you will say, well, what is it supposed to be doing? I mean, you need to have some kind of knowledge beforehand. It can come from domain experience or whatever. Any other ideas?
Yeah, I think depending on the output, if the output is well, let's say you have the game example is maybe hard to analyze what's happening on the screen because the output is just visual.
Yeah.
Something like this.
Mm-hmm.
I think the structured software is way more testable because each model you can, like, if it's many models and you know which output should be of each of model, it's really easy to catch the exact point where it appears.
That's also fair. Any other ideas?
I'd say, from my own experience as well, how well isolated the system is. If you have a system that's very dependent on external dependencies, you're going to have to mock a lot of stuff, which you already explained is not great. So I think probably how well independent, I guess is the word.
Yeah, that's also correct. Anything? I saw, yeah, there's a hand here.
And also, in my experience, a function that actually returns something is easier to test than a void function that just does something in the middle of itself.
Yeah, exactly. Anything else? So again, I mean, it depends on if you are testing on the UI level or the code level, but yeah, main concern is, whatever you guys have been saying. So the high complexity, the tight coupling between modules, dependence on global static states so that you are not returning something, but instead just changing a global variable. sequential coupling, the behavior of the function changes, depending on the order you call it. If you call something else first, then it will behave differently because of actually it might have something to do with this one. There might be side effects. You might be just calling getRange function, but it might be storing something in the database, and after a while it just overflows or something bad happens, and hard to manipulate inputs. Or maybe the function doesn't even have an input, and you have to create a file which will create something else, which will trigger a chain of events to provide that specific value there. And one of the best solutions to that is the clean code practices. And there is already a great masterclass about it. And you can actually check that. And while watching that, if you have already watched it, maybe you can now watch it again with the testability perspective. All the changes that is done on the code to have the clean coding practices also helps with the testability. So this actually gives you a good indication. I experienced it a lot in myself. I try to write a unit test for my module, and I realized that I am not able to pass a specific value for one of the variables because of the dependency that I caused. Then I realized that there is a code smell there. I'm not being able to write the test easily. Tells me that I didn't design my code in a good way. So, just for the sake of it, trying to run unit tests for whatever you are working on, it might help you see what kind of architectural or design flaws that you might have in your code. But having said that, I will end up with a trick question. How would you test a random number generator? Yeah. Not this one. that one is probably easy.
The best way would be just sampling. So if the set is random, there will be no tendency towards some value. But we need to also take in mind the size of the sample, because there is some threshold where before this we can manipulate ourselves to believe that, let's say, the random number generator is truly random, but exceeding this set, we start noticing that, okay, it's repeatable. So,
yeah.
As far as I know, the best way to test the random number generator is actually to compare kind of with the first you have kind of the quality. So it has quality for random number generators, and second you can measure with actual like some random something random. For example, like what is in radiation, like half-life of the radioactive particles. But also I think in mathematical analysis they have I don't remember how it's called at the moment, but they have some kind of quality that really can measure the randomity of some process.
Yeah. Okay.
I'd say test it a lot.
Yeah, I think quantify how random it is, like, and then you kind of need to use case, I think, because as he mentioned, there's like, you can kind of quantify like the randomness, I don't know how to really call it, and then see if that is random enough for you, is it good enough? Because random, I think it can never be truly random, it's always some base on it, I suppose. So yeah, I think, is it good enough for what you want to do with it? I think that's the most important here, so really it's all about context, I think. Because sometimes it doesn't matter if you get 3 times the same on sign of random, but like sometimes you really need it, like, yeah, large amount of randomness, I suppose. Yeah.
That's also good. I think there was one over there.
Yeah, you would, I think, need to do a lot of different tests on it, but one of them could be running it a lot of times and then looking at the last 2 or 3 digits and then comparing if there's more of one group. So then you can make a graph about the results.
Yeah, that is, I mean, kind of a simplification on the output data that you are getting, because you can also create the data with the exact outputs that you are getting as well. It's, yeah, but that also makes sense. Okay, maybe, yeah, why not?
Rather maybe comment, not necessarily how we can do it, but like just it comes to my mind that Steve Jobs said, if it looks not random, it's most likely random. That's why we make it less random to feel more random.
Yeah, actually, yeah,
So,
there was something like that. Oh, with the shuffle algorithm,
yep,
right, in
yep,
the music,
yep.
yeah.
So maybe that's the feeling.
Yeah.
About this.
Actually, I mean, it's a good case. I mean, what you were saying, all right, I mean, you have the correct intuition about that. And there are like real mathematical formulas about that, like chi-square testing, or there are tools. It had a very cool name. I can't remember it now, but yeah, there are existing tools that are created specifically to test if a random number generator is actually real random. And it is basically statistic analysis, and you create buckets, you generate maybe, I don't know, trillions of numbers or something, and you see if the distribution looks okay from the normal random distribution that you will expect. But it is something, I mean, it's a very valid feature that you might have, but it is something very tricky, and it is not something that you can improve with, those testability practices, unfortunately. That is basically the core lesson. And just like you said, I mean, the context here is also, again, important, because maybe if it is too random, the end-to-end user's feeling might not be that good, because if you don't know the story, the shuffle algorithm you were having with the songs, people were saying that, yeah, it is not random, it is always playing the same songs, over and over, and there is some weirdness. And they checked the code, it was actually random. It was just about the intuition. So they switched the random number generator so it can avoid recently played tracks, things like that. So it was no more, real random, but it was what the users wanted. So, yeah. It depends. It depends is, yeah, one of the things that you will probably remember about all this talk that we had. So, yeah, this is the takeaway from this. I mean, good code is testable, and good tested code is usually reliable. But again, it depends. There are a lot of factors that can affect that. And my final takeaway will be this one. Those ones, yeah, they are waiting for you. It's not about tools. It's not about what framework you use. It's not about, the numbers, the expectations, of your managers. It's not about that. It's about the mindset. You need to be a bit curious, a bit skeptical. Sometimes you even need to be kind of a hacker, actually. By the way, there was another story I will tell you about this. I started learning this just as a hobby, but some testers actually really practice on lockpicking. Anyone knows those kinds of testers? Yeah, one? There is a testing called physical penetration testing. And there's there's penetration testing where you try to infiltrate the server, for example, to try to steal data. So it is kind of like being a white hat hacker, ethical hacker. You get a contract to try to see if you can steal the data from the server, and you create a report about, what kind of vulnerabilities that you found. Physical penetration testing, on the other hand, really does it physically. For example, here, when I came here, there was a gate at the end. I passed through that. Then there was a security, the tourniquet at the entrance, and there was that. And I am sure there are things like server rooms that are there, rooms that I shouldn't be accessing. And the physical penetration testers, of course, they do it with their, with their understanding of, each other. They take the role, not do it for fun. They actually try to break in. They go to the door, for example, and they use social engineering skills. For example, I think I saw some of you playing ping pong. Maybe you, I don't remember. Maybe I could have tried, Yeah, guys, I am that guy. Could you just let me in? Victoria already knows that I would be here, and yeah, I could try doing that. And when I come in, I could actually try to break into a room and check if anyone actually saw me and try to stop me, or if I was able to block the cameras or anything. And that would be a physical penetration tester's life, but it is not a good way to end presentation. So I am going back to this slide. So yeah, don't forget. There are a lot of tools, there are a lot of methodologies, and you can just Google them depending on the language that you are using. But don't forget about it. Don't forget about these fallacies. Maybe you will forget, and I believe that you will be able to remember it like 5 years later. Oh, there was a bald guy, talking about that. I don't remember his name, but he said, yeah, this doesn't really work like that. And if you can do that, actually, that will be more than enough for me from this talk. So thanks, everyone.
Basil, can I have? Yes. Thank you so much, Omer. Exactly on time, huh? Fantastic.
Perfect.
Even a bit earlier than the. Yeah. We have actually another half an hour of Q&A, so I would like to continue throwing the catch box to the people that actually have questions. For the people at home, I would like to encourage you to go to slido.com and then include the event name is called Masterclass Testing, and I will be your voice, if that's okay, right? So I will read out loud whenever I see an interesting question, and then you could address it.
Yep.
Cool, guys. Who has the first question? Okay, Jasper. Okay, give me. Okay.
Is there code that tests the test code?
Sorry?
How do you test the test code?
That's actually a really good question. Who will guard the guards, or who will watch the watchman? So it's a bit tricky. Unfortunately, you usually don't exactly test the test code itself, but the test code is part of a series of frameworks, tools, and libraries that you have. If you are writing your own framework, and framework does not have to be a complex tool to integrate, it might just be some middle layer to create documentation or read input from files and things like that. What we do, for example, personally, we create tests, real unit tests for those framework pieces, but then the actual test itself, they are mainly just reviewed. But not just like a code review where you blindly check it. We track the results. We check if they are just randomly failing, for example, if they are flaky. And we also try to check if they are meaningful, things like that. Usually it just depends on the complexity, but you don't test the test scenario most of the time, but the remaining parts of the framework.
I would like to ask about documentation, because, every project, bigger project, is built by people, many people, and how to get confidence that, let's say, some sort of framework of documentation gives you enough information to, let's say, not only catch the effect, but also prevent it in some point of the process of creation of software?
Yeah, it is. Yeah, the basic answer is it depends. So it depends on the context. For the avionic projects, you will have sometimes up to 6-7 layers of requirements. It will start with the airplane shall fly. Like something very high level like that. And on the low level, it will say get range function should accept an integer parameter. Get range function should return something like that. And in that case, you have a whole bunch of different levels that you can review and compare to each other if the lower level is compatible with the higher one and if it is compatible with the code and things like that. On the other hand, for most of the projects, if it is not like healthcare or other stuff, Like the avionics I mentioned, I mean, the best thing you can do is traceability, I think, so that you can track how that is implemented or tested, and it can give some level of confidence. But otherwise, it basically boils down to the gut feeling. I mean, not just gut feeling, but the domain experience that you have, or the inputs from other domain experts. You know, you can have inputs from your customer and things like that. And unfortunately, there is no like a silver bullet that can give you, yeah, now you have complete documentation. You don't even have that for code, and documentation is a whole different piece.
I would like to take one of the questions from Manu. Can we also measure coverage for integration tests and end-to-end tests? If yes, how? Or it only makes sense for unit tests? Many thanks.
Yeah. Actually, in the industry, most people take coverage for unit tests, as asked here. You know, the main reason is if you are collecting coverage from unit tests, whatever you do on the above layers should not include any new coverage. And that's the problem. I mean, if you, yeah, in theory, for example, you should already have 100% coverage on a specific module that we showed you. You know, you cannot improve that with the integration test. So people just skip it on end-to-end tests and unit tests. However, it's really completely fine to do it on any level that you want. Actually, you can separate those results. You can say that these are actually, maybe you should even explicitly do that. You can say, okay, these are the coverage from the unit tests, these are the coverage from the integration tests, and these are the coverage from the end-to-end tests. And I mentioned that in avionics projects, there are very contractual, you know, strict requirements about how much coverage you have to have in code pieces. The bad thing is, back then, we didn't have any unit tests at all, like zero, now. And we had, well, I mean, even that didn't exist, I won't lie. I mean, there was something, but it was like basically checking if we can compile it or not. Yeah, I mean, right now we have all these continuous integration and continuous development practices. You know, whenever you submit a code, it checks the passes automatically and it gets integrated into your software, like immediately. You don't even see it happening. For us, integration would take like 3-4 days, sometimes even more, to actually make everything work together. So our tests were on end-to-end test level, and we were trying to cover those contractual obligations that we could cover in any level with end-to-end tests. So it is definitely possible, and the approach is not actually different, because to have coverage, basically it works like that. You instrument your code, and what it does is, maybe I can show it here. So we have this simple code, right? When you instrument it, it is either in assembly level or directly in the code. It says like print 1, print 2, print 3, print 4, print 5, print 6 to each level. Or if you have branches like that, you can have other instrumentation there. And when you run it, it will print, you know, a bunch of numbers to a file, and the software will know that, oh, that number is coming from here. Then I know that this line is covered. I didn't get the number, the unique number from this one, so I know that it is not covered. And as long as you instrument your application, it doesn't matter which level you get the coverage. You can get the coverage on the end-to-end test level as well. It is a bit tricky, it's a bit hard, but it is also meaningful, and you can absolutely do it. It's okay.
So you when you start to talk about your experience, well, it was no unit tests at all, and like so you have very long career in testing. So I would be interested to hear your vision at how it evolved from the time when you started on the testing in general, and what is the most recent technologies that maybe make it fully automatic, like artificial intelligence involved in this, or all this super high-tech modern.
Yeah. I mean, from there, actually, when we started there, our single test suite, you know, running our entire test suite will take around 1.5 months, completely manual. We will take, you know, hundreds of pieces of paper, sit actually real helicopter mockup, for example, for hours, and we will say, okay, press B1, that's B1, Okay, verify that airspeed is this, yes, and we will just really check everything. And that is why I started with automation, because that was boring. I mean, we still wrote the same tests. We didn't fall into that fallacy of just testing blindly, and our tests were meaningful with the requirements. But it was faster. When I left the company, there were discussions about writing lower level tests. We were actually trying to convince our managers that, yeah, it could actually be meaningful, but it wasn't easy because it was also new for the auditors that we were having. The other people that were working on the project, they were saying, no, I mean, that coverage doesn't mean anything because we need to have all the coverage from the end-to-end test level. And that was almost like a belief. But I know that at least for the specific company, now there are more component level tests, and now they can run their tests more efficiently. When I come to Netherlands, actually it is probably the first time that I got introduced with unit tests in like a business level. I liked the idea. I liked the concepts, but I didn't like how it was implemented. Unfortunately, even now, we are working with different teams, and some team produces something, the other team integrates it into their own component and uses that. Almost every team has this dilemma. The component they gave us, is it really well tested? Because no one has the time to go over other people's unit tests and like meticulously analyze it against the requirements and everything. You want to believe that it is okay, but it unfortunately doesn't happen. Maybe it could be avoided if people had this presentation before. But this is the thing. I mean, those fallacies, I mean, it's really bugging me, but it is not something, you can easily fix. What I'm trying to fix it is basically this, try to teach people that you need to be careful about what you're doing. So in theory, unit testing, all those, integration level testing, everything, they are really, they have a great merit. But on implementation, most of the time, unfortunately, it is not, I mean, I won't say it fails, but it is not up to standards that they should be.
Can I have a question about the test-driven development? So I'm trying, but what I've found is that to write a test, you need a clear idea about the function, about what it's about to do, what its input is, what its output is.
Yeah.
And sometimes you just don't know. So, what's your advice in that case? Or let's say, maybe you know on a higher level, you do know what the program is supposed to do. You could write it. Well, maybe hard to write a test, but yeah, it's a conflict sometimes that I just don't know what the function is supposed to do yet.
Yeah. Well, I mean, one thing, if you don't know what exactly the function should be doing, then you should not be writing it yet. So you should not be writing it yet then.
Well,
not even the test. I mean, if you are not sure what the code will exactly do, then, I mean, where's the point in starting with that? But I understand your point, because you have an overall idea, you have a high-level idea about how things will connect and work, but for that specific function, it is not clear yet. And that is why I mentioned that you can even use the inverted pyramid. And even inverted pyramid is okay to use test-driven development, because you can write your end-to-end test and implement everything, until it is required to actually make that thing work. That is also okay, and it depends on your context. And if you are working on a small project, that is really completely acceptable. And actually, even for a larger project, maybe you can still create the end-to-end test, and once that end-to-end test passes, it will be the signal to you that feature is now ready for deployment. So it won't exactly be in the merit of test-driven development, but still, I mean, you can make use of it in this way, in whatever logic it fits your, thoughts. I can't.
Yeah.
Yeah, maybe let's go there because she was raising it for a long time now.
Yes, I had a question about testing as a career path that Danila kind of touched on, which is that what do you think about the future proofness of testing? Because you mentioned AI, that I presume it's kind of on the horizon. How close do you think that horizon is? Because you already have currently AI tools that, for example, autocomplete code and stuff like that.
I mean, yeah, for AI, actually, it is hard to say. I don't know if you guys saw DALL-E. It can generate images from, the sentences that you give. And it's scary because if you told about it like 2 years ago, they would say, yeah, it's crazy. Probably it will take around like 15 more years, before we can implement something like that. And now it is here. Now people are actually using it. For AI, I mean, I am not scared of the future of testing because if I would be, then developers should also be. I mean, because in the end, turning requirements into code is also something that is not really hard to do if your requirements are well-defined. So, and it is about communication. And AI is getting better and better at understanding the context from even natural language. But for example, those AI developments, I see it as an opportunity. I mean, really, there are a lot of open points you can do. You can check the bug history to actually guess, potential new bugs that will come in the future. You can check your performance history, use some machine learning and generate potential performance pitfalls that you can encounter, and even use AI to automatically generate, some of the test code. In that sense, it is more like an opportunity, I would say. But in general, actually, the career path of testing is a bit interesting because, yeah, I also heard it in a conference, and it makes sense because test engineers usually start as test engineers, like me. They switch to test automation because it is more fun. Then they switch to development. Now you have years of experience about testing, all these fallacies, approaches, and stuff, but it feels boring. Because you are writing scripts anyway, they are doing it for you. I mean, and you are not getting paid by the bug or anything. Once you start writing automation frameworks, you will have a tendency to switch to a development side as well. Actually, I was talking with that about my manager. I think in the last 1.5 or 2 years, I didn't really write a single test. I am mostly working on the infrastructure and things like that. And it's a bit weird, and even after that, I am still here, talking about testing. Another point is, it's also a bit tricky because testers also don't always have the respect. Testing is so taught to be, you don't need as much technical skills as the developers. So you might get a different pay, a lower pay grade. You might have other problems like the visibility. Things like you do with testing is not as visible as someone will do with development. Unfortunately, there are challenges like that if you want to follow that path. Having said that, it is still a good idea. For example, if you want to sneak into a domain that you are yet not experienced enough. You want to work in, I don't know, AI, for example, but you have no idea as a developer, how to work on AI, but you can, work as a quality assurance engineer, manual test engineer, something like that for that website, so that at least you will get into it and you can continue from there. I mean, it's a bad advice. And it's a good career. I mean, for 16 years, I've been asked a lot of times, why are you not just switching to a developer? But I like testing. I like breaking things. And if you like breaking things, I mean, you just give it a try at least. And to be honest, I mean, even as a developer, I mean, you should. There are some companies which makes rotations. So each developer should spend like 2 weeks per year as a tester, something like that. Or sometimes. At each sprint, one of the developers wears tester set, and for a week, they become the tester, and they don't focus on development but just testing. It is, yeah. I mean, I can say about, all I can say is these details, and you can, decide yourself about the career path part. I guess.
Okay,
No.
guys, last question, okay?
Okay.
Last question. In the front, Saladin.
Opa.
Oh, watch out.
So somewhere you said that if you can't write a test easily, it means that you're not designing your code well, or your
something like that,
test,
yeah.
something like that. And I have the problem nowadays that usually, okay, it starts with just something simple. Check if you have enough argument count or arguments. It's just like, okay, if it's not 2 or 3, you just pass false, blah, blah. It's just an easy call. And then later on, I have something more difficult with, for example, linked list, where I want to check if the linked list is, well, initialized, or if the data in the linked list has been modified correctly. And when I have to do that, I get like these huge chunks of code where I make some sort of like a separate program, and then I only return false or true, but I'm not actually testing the data itself in the tester, but not only with an assert or something like that. And then my question is, what am I doing that I'm questioning every day? But more, just, when do you know that you write too much code for your tester? For your like separate test blocks, yeah.
I mean, as always, it depends. But I mean, it's just liking a mock, because sometimes people write mocks, which is almost a duplication of the real system, you know, and it tells you something. One approach, I mean, it's not the only thing. For example, we call it the Beyonce rule. So, that's about if you like it, you put a test. That was the Beyonce rule. The other one is, if you can't find the simple name for your test, then that test itself is too complicated already. The test should be focusing on a very specific aspect of the thing that you are doing, at least on the unit test level. This can give you your first hint. And on the other one, you can actually still break it down. You say, for example, linked list, and finding if an item is at a specific point, for example, searching for it. The tests, I mean, it is always a good thing if the tests are independent, but you can also have sequential tests which need to run one after other. And for that, you can start with creation of the linked list. Then you can use the data output, the verified data from that one, and use it in the second step. Use the verify data and pass it to the third step. Things like that.
That makes sense.
So that might be a trick that you can use in that sense.
Thank you.
Maybe.
Can I have the microphone? Yes. Thank you so much, Omer, for the insights. I realized that this is actually an art in itself, and I wanted to ask you the last question. How many test experts are there in TomTom? Like, I guess for this sort of big companies, there are like teams of you guys, right? So I was wondering how many of you are there?
It's hard to say, actually. I mean, I really don't know the exact number, but for each project, there can be, for example, for an integration project we had, I think our team had like 7, 8 dedicated testers who were focusing on only the end-to-end tests, and the developers were like 40, 50 people. And in avionics, for example, this can get bigger if you would have 50 developers and 30 testers, because we had to create a lot more tests. So I can't give you an exact number, but yeah, we have a lot of domain experts and very dedicated testers, that are focusing on a very specific aspect of our software.
That's really impressive. And I wanted to emphasize to you guys that this is also maybe a sort of a career that you want to pursue, right? Many times students come to me and they feel a little bit insecure about their internships and so on. They say like they have big ambitions, but they are in doubt about their own capabilities. And one thing that you actually mentioned that I thought like, that's actually a good tip I can always give them is like, if any of you you want after your Codam core to do an internship in AI, but how much did you learn about algorithms? Not that much. Why don't you take an internship in testing into a company that does fantastic AI? And then by reviewing code and testing it and so on, you can actually develop yourself in the domain. That's also a way. Like honestly, this is my biggest lessons learned because this is the type of advices I need to give to the students. So thank you so much, guys. Let's give a round of applause to Omer. Of course, a bag of swag. A bag of swag with our
Great.
Nobody has yet the Codam cup. Only you. So you'll get them soon. Not yet, but
Can I show
you'll
off?
be the first one. Yeah, in the white box.
White box testing already. Okay. Yeah, I will show.
And of course, a bottle of champagne because Corinne always says, life is too short to drink bad champagne. So.
Thanks.
Okay, round of applause once again, guys, and for you too. Thank you.
Also, thanks to you for the opportunity and thanks everyone for joining and for the interaction. It really went great. Thanks a lot.